Welcome, Calculus BC. This is lesson 5.5, log integration. Let's go. So here's the rule for log integration. If you integrate 1 over x dx, you get a natural log of the absolute value of x plus c. And this kind of makes sense. Think this only works for like 1 over x. It doesn't look for 1 over x squared, because if you think of your power rule, 1 over x is the same thing as x to the negative 1 power dx. If we wanted to follow the power rule when we integrated, we would have set x to the 0 power divided by 0, and that doesn't work because we can't divide by 0. So this is kind of like a special case. Like, you can't use the power rule. You just have to, you integrate that, and it's going to be natural log of the absolute value of x. Why does it have to be the absolute value? Well, one thing from logs you remember from last section is logs, you can't have a negative inside of here. So if you had like a negative right here, you couldn't also have a negative, like we got to make that a positive. That's going to be our area under the curve. So make sure you have the absolute value sign and always the plus c. Anyway, so let's practice a little bit. So the integral of negative 3 over x is just, you can think of this, I'm going to take the negative 3 to the outside of 1 over x dx. So antiderivative negative 3 ln of absolute value of x plus c. Pretty easy. This one, even though it looks weird with p's, just treat them like x's. This would be a u sub in this case, so it's going to be p squared plus 1. And that means my du would be 2p dp. I have a p dp, so I need to make a 2 and then multiply by 1/2. So when I do my u sub, I'm going to get integral of 1/2 integral of 1 over u du, which is 1/2 ln of absolute value of x, plus c, u plus c. So 1/2 ln of absolute value of p squared plus 1 plus c. So one neat thing here, p squared plus 1, this could never be a negative number because it's always going to be positive, because you square a number, you get a positive. So you didn't put the absolute values, you're fine. And yeah, you could have put this 1/2 up for a power rule, but you don't have to do that. You're good. All right, let's do another example. So that looks weird too, and this is the case where like it's going to be u substitution again. U substitution problems can look kind of funky when we're doing it with lns. So it might be hard to see sometimes. And this is the thing you got to think when I'm doing it with lns. There's like the hidden 1 over x. And then, derivative of this is going to be ln of x. So my u in this case is actually going to be 1 over x. And du is ln, no wait, I'm doing that backwards, right? Yeah, I'm doing that backwards. Okay, I do this sometimes. So the u is going to be ln of x. What's the derivative of ln? Oh, man. I'm not cutting this. All right, derivative of ln, I am right, is 1 over x dx. So it's kind of hidden there as the 1 over x dx. So when I substitute this in, it's actually just going to be u du, because it's just all canceled out. So it's going to be u squared over 2 plus c, which will be ln of x squared, absolute value, sure. No, you don't put absolute value. But if you did, you're not. Nah, I don't put absolute values. You're not wrong. Plus c. Oh boy, not a good day. Other rules. So sometimes they show you these rules for tangent, integral, tangent, cotangent. I don't think you need to memorize these. But I want to show you how you could get these. And even if you didn't have this memorized, because it's not going to pop up, it's basically a u substitution problem. So I'm going to integrate cotangent. Now, cotangent is the same thing as cosine over sine. Cosine of x over sine of x. All right? So this is just a u sub problem with logs. So my u in this case is going to be sine of x. My du becomes cosine of x dx. So we have our cosine of x dx. When I sub in, I get the integral of 1 over u du, which we just learned is ln of absolute value of u plus c, which is ln of absolute value of sine of x plus c. Wow. That's the formula. Cool. We're done.